fourth least common denominator. From here on out, I'm just going to call it the LCD. Okay, first of all, let's just review with plain numbers how we might find a common denominator. First of all, let's just think about what we can do to a fraction like 3/7. If I wanted to change the denominator, let's say I was doing this so that I could add fractions, right? So if I am working with a plain old fraction like this, and this is all I've got. Let's say I know, oh, I need to change that 7 into 35ths to add it to the other fraction that's already in 35ths. What would I do here to finish this? Basic fractions, nothing tricky here. Brian? We go, oh, I must have multiplied that denominator by 5 to make it into a 35. So whatever, first of all, remember, whatever we do to the denominator, we have to do to the numerator or vice versa. That we can make an equivalent fraction that has a different denominator by multiplying both numerator and denominator by the same factor. Okay, so that should be very much review. Here's how we're going to apply it to algebra. First of all, let's take a look at one that does have a variable in the denominator. So still just monomials, right? We haven't even gotten to binomials and trinomials yet. That's next. So first of all, you're going to be asked just to practice with some fractions like this, where you're given a new denominator, and you have to find the new numerator. So just like we did on that last one, you guys could do, like I did up here with the plain numbers, you guys can do this almost automatically. But what we're thinking to ourselves is, what did I multiply by 7 to get it to be a 35? Oh, I multiplied it by 5. So let's try the same thing down here. What would I need to multiply 3a by to get it to become 18a squared? Carissa?
6a.
Times 6, good. 3 times 6 to make the 18. And to get from a to a squared times another a. Exactly right. Now, what we have to remember is to multiply the numerator by that same factor. If it was times 6a, it's times 6a. 8 times 6, 48. Times a, 48a is my new numerator. This is an equivalent fraction. It's not simplified. Don't simplify this, guys. It'll just take you back to where you started. Right? If we could simplify this, we could go, hey, those both divide by 6. And a I can get rid of 1 and 1. And guess what? Then we're back to here. So we're just completing an equivalent fraction by finding the missing part. Does that one make sense? Okay, good. Then let's make it harder. Not too hard yet. Don't worry. Don't worry. I'm going to warm you up to it. I know you've been on vacation. 2 over x minus 5 equals something that has a denominator of x minus 5 times x plus 1. So to begin with, all you're going to be doing is creating equivalent fractions where you're given the original fraction, you're given a new fraction, and you're given a new denominator. How can I get from this to this? Think about it this way. This doesn't have parentheses, but I could add them. And now think about this. What do I need to multiply this binomial by to get it to look like this? Diego? Yeah, well, the only thing that's missing is that second binomial, right? The x plus 1. Oops. So if I say, oh, I need to multiply this by that whole binomial. Can you guys see in the back? Can you see the yellow? Does it show up? It looks bright up here. Okay. I'll stop using it if it doesn't. So 2 times x plus 1. Well, let's just leave it that way. 2 times x plus 1. We're not going to do anything else with it now. Later on, we'll have to try to simplify, but we're not simplifying here. Again, if you simplify, it'll take you back to what you started with. Let me do one more that's kind of like that. Let me find another one that's similar here. Right, they have it. Here we go. Actually, let me change it. Let me go on again. Notice that you're looking at what it was originally, what it's going to become, and you're figuring out what you need to multiply it by to get it to become that. Some of them, you're just going to complete like this. So the first step is just to complete the missing numerator. by multiplying by that factor. Now, actually finding the LCD. We haven't done this yet. Find the least common denominator. I'm going to start with numbers. Let's say I had just fractions, 3/4 and 11/30. Let's say we were going to add these, because guess what? That's our next lesson, is adding fractions. If I wanted to add these together, I can't add them because they don't have the same denominator. Here's my suggestion for, first of all, for plain numbers, is to take the bigger one and start listing multiples. 30. Okay, 4 doesn't go into 30. 60. I know 30 goes into 60. Does 4 go into 60? Yes. So, if we're just finding the LCD, then we go, oh, 60. But now, if it says rewrite the fraction with its LCD, that means now, okay, we found the LCD. LCD equals 60. But now to rewrite the fraction means to go, okay, what did I multiply by? And let me give that new equivalent fraction. So 4 times 15 is how we get 60. So 3 times 15, 45. There's the equivalent fraction using the LCD. 30 times 2 makes 60. So 11 times 2, 22. So if it asks you to rewrite the fraction using the LCD, first you got to find the LCD, and then you have to do those equivalent fractions. So let me show you. This is where we're putting it all together. I'm going to give you 2 more examples. Okay, so find the LCD. Now, first of all, if it just says find the LCD, then that's all you have to do. So on this one, this is all we're going to do. Find the LCD for 3 over 6x minus 30 and 8 over 9x minus 45. Just like we were doing at the beginning of this chapter, you have to factor first. We have to factor to see what denominators we have. I'm going to put this back up in just a second, but let me just go back to this one in green. This was already factored. If I FOILed this right side, this would be a trinomial. So this is already factored for us. Now we have to factor. So I'm going to start with the one on the left. 6x minus 30. All I can do is factor out a 6, which leaves x minus 5. If I factor the denominator of the second one, all I can do is factor out a 9, which leaves x minus 5. So if I wanted to turn these into having the same denominator, notice, first of all, x minus 5 is already the same. So I don't need to change that. If I said turn this into an equivalent fraction, well, I would keep the x minus 5. Running out of room on this one in the middle. I could turn x minus 5 into x minus 5. I would just multiply by 1, right? Nothing changes. All I have to do is now find the common denominator for 6 and 9. Again, x minus 5 is already in both. So if I was going to make these to have the same denominator, they already do with the x minus 5. The only thing that's different is the number. So I need to find the LCD for 6 and 9. Again, if you're not sure, take the bigger one and start listing multiples. 9, 18, wow, 6 goes into 18. Guess what? 18 times that x minus 5. Now, if all it said was find the LCD, we're done. There's our LCD. You don't even have to box it twice. You can just box it once. It's the same answer. Did that make sense how I got that LCD? Kind of. I'll do another one. I know, kind of. Okay, let's do another one. We'll do 1 or 2 more. Okay, how about a trinomial? 9 over x squared minus 8x plus 16. Now I'm going to go ahead and write this second one underneath, because this one, after we factor it, we are going to rewrite these with their LCD. So we're going to find equivalent fractions. So 9 over x squared minus 8x plus 16. 5 over x squared minus 7x plus 12. First thing I need to do, factor. Factor first. 9 and 5, numerators, I can't do anything. Denominators, I have two trinomials. Either the square of a binomial or reverse FOIL, whichever you prefer. Oops, thank you, a double parentheses there. X minus 4 times x minus 4 for the first denominator. For the second denominator, reverse FOIL, x minus 4 and x minus 3. So again, I've been saying this all along, if you can't factor, you're not going to be able to do this because factoring is key. So I keep saying if you have trouble with factoring, please see me. Nobody has seen me. So if you don't want help, that's up to you. Now, first thing we need to do is to find the LCD. We need to take the largest amount or power of a common factor. So what I mean by that is that this first fraction has two x minus 4s. This second fraction only has one. I need, if it's in common, so first of all it's in both, then I need to take the largest amount or power. That would be squared, or this first one 2, right, squared. So my LCD is going to be x minus 4 times x minus 4. I need both of them. And I need the x minus 3. So if it's in common, if it's a factor in common, you take the biggest amount. So since this first one had 2, we need 2. The second one had an x minus 3, and we need the x minus 3. Let me show you why. Let me continue this. If this says find the LCD, first of all, here's our LCD. But the second part of this is going to say rewrite the fractions. I'm going to take this first one. It's kind of disappearing, but up here, 9 over the factored form, x minus 4 times x minus 4. That's my original fraction. I just factored it. If I need to now, I found the LCD, I need to now turn this denominator into this. This is what we started with. What's different? And so maybe here you can see, this has 2. If I only had 1, let me scoot it up, there we go. If I only had 1 x minus 4 in my new denominator, I can't take this and turn it into this. There has to be at least this much, plus maybe something else. So, again, what do I need to multiply this denominator by to get it to look like my LCD? What's the missing piece, Izzy? What? Well, times 1 is going to make it the same. It won't make it look like this. Anything times 1 is just itself. So if I multiplied it by 1, it wouldn't change. I need this to look like this. What's in the third one, in the second one, that's not in the first one? Luke?
Times x minus 3.
Yeah, the only thing different is this, right? So guess what I would do to this? I would say times that x minus 3. If I multiply the denominator times that, well, now it's there. If I multiply the numerator by it, well, now my numerator is 9 times x minus 3. Let's try it with the second fraction. The second one was 5, and again, I'm using the factored version. It's off my screen here, but it's in your notes. X minus 4 times x minus 3 is how we factored that one. My LCD that I figured out, x minus 4, x minus 4, x minus 3. So again, the first step is to find the LCD itself. The second step is to take the original fractions with their factored denominator and turn them into this new LCD form. So on this second one, again, we're always just going to look at the original denominator and then look at my new denominator with the LCD and think, what's not in this first one that's in the second one that I need to multiply the first one by to make it match? Kate? Yeah, we've got 1 x minus 4, we've got the x minus 3, this has a second x minus 4, So I need to multiply it by that second x minus 4, 5 times x minus 4. Now, one thing, let me just go back and do a couple more of just finding the LCD. Okay, so finding the LCD, let me give you a couple more and we'll just practice finding the LCD because I know that's tricky. Find the LCD, and so I'm just going to do the denominators. We're not even going to bother with the numerator here. What if I had an LCD of 4x minus 6, or I'm sorry, I had a denominator, not an LCD, a denominator, and 6x minus 9. And I said, find the LCD. What do we do first? Diego? Factor first. 2 times x minus 3, and 3. Whoops. 3, I wrote that wrong, times 2x minus 3. I wrote that wrong again, didn't I? This is also a 2. Hold on, sorry. 2 times 2x minus 3. I went too fast. Okay, 2 times 2x minus 3, right? Because 2 times 2x is 4x. 2 times 3 is 6. 3 times 2x, sorry, I made a little mistake there. Now, look at what's the same. I have a 2x minus 3 in both. So that is going to be part of my LCD. Take the number out front, 2 and 3. What's my LCD for 2 and 3? Least common multiple, least common denominator. CJ? 6. There's our LCD. Now if it said rewrite the fraction using the LCD, you would take each of the originals, you'd figure out what do I need to multiply the denominator by to get it to look like the numerator. Let's do one more. Last one, just finding the LCD here just for practice. Let's say that you're now going to find the LCD. So again, I'm just going to give you, this first one is already factored. So there's one denominator, we're not even going to bother with the numerators. Just practicing with the denominators. X squared plus 4x plus 4. So this one's not factored. This one's already factored on the left. So factor first, already done for us. Denominator on the left, not factored. X plus 2 and x plus 2 would be the factors. I'm going to lightly just cross out the original trinomial. We're not going to use that again. We're going to stick with the factored form for the rest of this. So, the LCD. If it's in both lists, or both denominators, we have to take the biggest amount. Anybody want to try to do the LCD for me? What do you think? What do you think we're going to have? Kate? Perfect. We need both x plus 2's because it's twice in one fraction. So the bigger amount, if it's in both, we take the most that it shows up. And then anything else that's there. If it's in any denominator, it has to be in our LCD. Otherwise, we can't write common fractions with that denominator. Okay, so we're going to start with the beginning where you're just filling in the missing numerator, and then you're going to have some like this. It's a combination of both.